Thank you, Lorraine. Hi, everyone. As Lorraine mentioned, I work as a consulting software engineer at LexisNexis, and today I'm going to talk about how I've used the ECL Work Unit Services standard library functions to capture details about work units that are running in Thor, and then created a report in Power BI to monitor the system using all of the information I gathered there. So before we get started, I have a quick poll question for you. Are you familiar with Power BI? You should see the poll question at the bottom of your screen. So take a moment to answer, and we'll review your answers later in the talk. All right, so here's a quick overview of the topics I'm going to cover. First, I'll demo the HPCC Thor monitor in Power BI so you can see what we're reporting on and how we're using the information. Next, I'll talk about the Work Unit Services standard library functions I'm using to collect the data that is the back end of the Thor monitor. And finally, I'll talk about how we're getting the data from Thor to Power BI. So I'm going to switch over to sharing my screen now so that I can show you the HPCC Thor monitor in Power BI. Let's see. All right, so here's the Thor monitor. You can see there are several pages to the report along the bottom of the screen. I'm not going to cover all of them, but I'll show you a few of them to give you an idea of the data we're capturing and how we're using it. This page shows a list of the collected work units and the information we've collected about them. On each page, what you'll see are some drop-downs on the left and the top to allow you to filter to what we're interested in. We collect data from multiple Thor environments here, so one of the filters allows you to select which environment. Right now we're selecting Alpha Prod, but there are other environments you can choose from, and it will filter the list based on that. You can also filter on other details, like what cluster the work units ran on, what state they're in, who the owner is, what ECL version was on the system when the work unit ran, and also specific job names. So for example, if I'm only interested in looking at work units run by myself or another specific user, I can filter by owner. So I'll just pick one randomly here, and this will filter down the list to just the work units for that specific owner. All right. And then the tool defaults to showing you work units from the last week. We're keeping history, so you can expand that to a longer date range if you want to see more history, or you can reduce the date range to just the last day or two. I'm going to switch over to the potential problem work units page. All right, so this page shows work units that took longer than typical to run. Let's see if I'm waiting for it to load. There it goes. All right, so on this page what you'll see is the total time here is the time that the work unit took in seconds, and the standard deviation and average are calculated for all work units with the same job name. The z-score is the number of standard deviations away from the average that this work unit's total time is. So the higher the number, the more time it took compared to average. So for example, this first work unit took 246 seconds to run. The average time for the 110 work units we've collected with that same job name is 26.73 seconds. So the time for this work unit is 9.83 standard deviations away from the average, so it took a little longer than normal. This gives us the ability to investigate potential issues. If we're seeing a bunch of high z-scores, it may point to an issue on the system as a whole. If a particular job is suddenly getting them, maybe something's going on with that particular job. As I mentioned before, you can also use the drop-downs to filter the list to the work units you're most interested in. I can filter to a specific job and see all the work units with that name and how it's been performing over time. I can also sort the table by date instead of z-score and be able to see if the time has been slowly going up, or maybe the problem work units are just in there and were anomalies. And I can also filter on the time that it's taking. So maybe I'm not interested in ones that are only taking 246 seconds, even if that's longer than average. I could filter it to work units that maybe took at least 2,000 seconds to run, and see those only. The next page I'm going to look at is the total time by date. All right, so on this page, the top visual shows the total time in seconds day by day for the last week, which is the default date range. This is for all work units in this environment right now, so you can see, March 17th was the busiest this week. The bottom visual breaks down the total time to show the compile time, Thor time, process time, and DFU time. And both visuals can be viewed at a year, month, day, or individual work unit level. It starts at the day level. If I change the date range to include February, so I'll make this the last 8 weeks. Uh-oh. It kicked me out of my screen share, so hold on. All right, there we go. All right, so now I'm looking at the last 8 weeks. I can use this little button up here in the corner to drill up. And when I drill up, it will show me month to month instead of day to day. So I can see, this is only picking up a couple days of January, so it looks way lower, but I can see February compared to March at this time and how much total time. I can also drill down to a work unit level if I want to filter to a specific job name. So I'm going to filter to a specific job. So I'm looking at the Clue Auto Daily Build job, and this particular job usually runs 2 times a day. So this right now is showing me day by day, and I can drill down using this little button here in the corner. And now it will show me work unit by work unit, how much time it's taking. All right, there we go. So now I can see each work unit over the last week and how much time it took. And I can do the same type of filtering, drilling up and down on the lower chart as well. So the next page I'm going to show you is the graph timings page. All right, on this page, it allows you to compare subgraph timings for a job over time so you can investigate issues. So we filtered to the Clue Auto Daily Build job on the prior page, and it retained that filter when switching pages. So we're looking at the work units for that specific job name. The whole bar is showing you the total time for each work unit, and each color in the bar is showing a subgraph duration. So you can compare side by side how subgraph timings have changed. This one in the middle that looks like totally different colors is one that I looked it up ahead of time, and it's one that was restarted at a different point, so the graphs don't quite line up. But for the other ones, you can see, this dark blue color is graph 14, subgraph 1106, and you can see how it's comparing over time if for some reason that particular graph started to get bigger over time, or something got smaller, something's not lining up quite right. So you can hover over a color to see which subgraph it represents. You can also filter by the graph number to look at only one graph. So some of these have so many subgraphs that you get so many colors you can't quite tell what's going on. So I'll filter it to just graph 14. All right, so when it filters down to graph 14, I'm just waiting for the screen share to catch up with me. All right, it kicked me out of my screen share, so let me get that fixed. All right, we're back. All right, so here now you can see that we've filtered down to graph 14, and you can see the subgraphs and the colors there a little bit easier. All right, and the final page that I'm going to show you is the errors page. I'm going to go ahead and take out my filter for jobs so that we see everything again. So on the right-hand side, what you'll see is the total number of work units with error and the percentage. So for the 9,896 work units that have run in this environment in the last week, 147 of them have failed, which is a 1.49% error rate. The pie chart shows errors by error code, so you can see which error codes are thrown most often. And the top table shows job names that have at least one work unit with an error. It lists the number of work units with that name, the number with errors, and then the percentage with errors. So for example, this CT marital status rebuild has 5 work units that have run in the last week, and 4 of those have failed, so it has an 80% error rate. Not too good. But if I click on this one up here, what will happen is the bottom chart will actually filter to show me those specific 4 work units that failed and what error messages they received and other details about those specific work units. So that's everything I have for the demo, so I'm going to switch back to the presentation. All right, so now let's talk about the Work Unit Services standard library functions that I've used to collect the data that supports the monitor. The first one is Work Unit List, and Work Unit List returns a list of work unit IDs with details, including things like state, cluster, owner, job name, some of the things that we saw in the monitor. You can set parameters when you call it to collect a list of work unit IDs based on various attributes. So for example, you could pass a username and get only the work units for that user. You can also specify if it should return work units that have been archived or not. What I'm using are the low work unit ID and the high work unit ID parameters so that I can capture a list of non-archived work unit IDs that have run within a date and time range. So I'm passing the start date as the low work unit ID and then the end date as the high work unit ID, and then I get here's like an example of what I get back, and I get a list of all the work units that have run within that range. So once you have a list of the work unit IDs you're interested in, you can use other functions to get details about those work units. Work unit timings will return the time spent in each step. So in yellow, you'll see an example of how this function reports the graph timings. I parse this to collect the duration for each graph and subgraph to support the graph timings page that we looked at. I have noticed that if the work unit ran on Thor, the name looks a little bit different, so I have 2 regular expressions to pick up either type of value. I also collect the compile time, which is shown in purple, the processing time, which is shown in pink, and the DFU time, which is some of the entries with spray or despray in the time, which is shown here in teal. The work unit timestamps function returns the timestamps for each of the steps in the given work units. So I'm using this to collect the start time and the end time for each work unit. The start time shows up with an ID of created and an empty application value, which is in yellow. And the end time shows up as an ID of finished and an empty application value, which is shown in purple. I have seen that there can be more than one finished entry with a blank application value, so I always sort and capture the latest one to get the end time. The last function that I'm using is the work unit messages function, which returns all of the messages associated with the work unit. It'll include informational messages, warnings, errors. I'm using it to capture the errors for the errors page that we looked at, which are noted as severity of 2 when you pull back the messages. And a work unit can have more than one message. It could have an informational message as well as an error. It can also have multiple error messages depending on what went wrong. So here's a simple example of how I'm using the work unit services functions. Here I'm capturing the error messages for all work units that ran between February 26th and February 27th. So first I'm capturing a list of the work units in the date range using the work unit list function like we talked about before. Then I project that list and call the other work unit services functions within the transform to create child data sets with the timings, timestamp, and messages details for each work unit. If you're not running on HThor, you need to wrap the work unit services call in no Thor because it cannot run from a Thor slave. And once I have a list of the work units, I normalize the messages from the child data set, skip over the messages that are not errors, and strip out the new lines and tabs from the messages. And this is just kind of a simplified example of what I'm doing. And on the next slide, you'll see what I end up with is a data set with all of the work units that ran between 226 and 227 with their error messages. So I'm doing something similar for the graph timings and the other work unit details. So now that I've shown you how I'm collecting the data about the work units, I want to show you how that data is getting to Power BI. So as I mentioned before, we're collecting data from multiple Thor environments. So I have ECL code using work unit services functions that runs on each of the Thor environments to collect that data, and it outputs 3 data sets. One with the list of work unit IDs and the details from work unit list and work unit timings. One with the graph timings for all of the work units with 1 record for each subgraph, and one with the error messages for all work units with 1 record for each error message. Next, there's ECL code that's running on one of our Thor environments that collects the data from each of the other environments, combines it all together, does some minor transformations, and joins it with the historical data. And next, we have ECL that's despraying that data to a server where a script then picks it up and loads it to SQL Server. So once it's in the SQL Server tables, Power BI can connect to SQL Server and pick up that data, and it understands the relationships between the tables and allows me to create the visualizations that we looked at. All right, so we are working on adding some additional features. So for my final poll, I'd like to get your input on what other monitoring feature you think would be most beneficial. Your choices are DFU tracking, so you can see details about DFU activity similar to the details about work units. Cluster efficiency, so you can see how many work units were running on each cluster by hour. And potential problem graphs, so you can see when certain graphs took longer than average time, similar to what we saw with the potential problem work units for total time for the work unit. Or maybe you have another idea, so feel free to email me any other suggestions. All right, so thank you so much for your time and attention, and with that, I'll turn it back over to Trish.
Thank you, Jessica. You know, this is such an interesting topic given the importance of Thor and its role in the platform and making sure it runs optimally in our environment. So what you've done with creating this tool is simply amazing. So thank you for that. And while you go and review the questions that have come in from the audience, I see a few there, I will share the results of your first poll question. And you had asked, are you familiar with Power BI? And it looks like an equal number of responses of 27% answering yes and just a little familiar with Power BI, while 45% said no. So hopefully what you presented here will be helpful to all levels. So with that, are you ready to move on to some questions?
Sure.
Okay, so let's start up top. is the calculation of statistics like standard deviation and z-score done in ECL or Power BI?
It can be done in Power BI using calculated columns and measures, and I started out that way, but I had some issues with performance because of the volume of data, so I actually am doing that calculation in ECL using the average, variance, and like square root ECL function. So I'm calculating that and then loading that into SQL Server for Power BI to pick up.
Interesting. Okay. Another one, what systems and tools were used in combination with HPCC systems to build the Thor monitor?
So in addition to HPCC, we also obviously used Power BI to create the front end. SQL Server is being used to store the data for Power BI to interact with. And a Windows server is being used with scripts that load the dspray files into SQL Server and automate executing the jobs on each of the environments.
A little hodgepodge of different things to make it work.
Yeah.
And a couple more here. Can you use the ECL work unit services without Power BI? And how does the work unit services extend the ECL watch work unit dialog?
So certainly you can use the work unit services without Power BI. You know, whatever, if you have a need to get all of that information and do whatever you want with it, if you're calculating statistics, if you're, you know, trying to load it into something different for your own purposes, you can use that. Power BI is just how we chose to create the front end part. And work unit services allows you to get all of this information. You know, as you saw, you can get details about lots of different work units at once and do different manipulations with that, and be able to see how, you know, collect over time all of that information into a database or into even just data sets, whatever it is that works for you.
So it sounds like you're using the best of both worlds to make it work. I like it. All right, and we've got time for one more question. This is a good one. So since the platform is open source, is this tool available to the community? But if not, could someone create the tool in the way that you did to monitor their own HPCC systems environment?
Right, so the tool isn't directly available, but absolutely you could set up you can use work unit services to gather the data on your own system and set up a similar tool. Power BI specifically can connect to many different types of data sources, so it can connect to CSV files, Excel files, many different types of databases. So you don't have to have SQL Server. You have a lot of options for how you store the data that you're gathering with work unit services. Even you could use a different front end if you have something else, but Power BI specifically is free to download and develop on your own system as far as I know. It does require licensing to share it on the cloud out to others in your organization, which is what we're doing here. So while we can't directly give you this tool, I think if you use work unit services, you could develop something very similar.
Okay, thanks for sharing that with us. A couple more questions came in, so if you want to look at those, if we have time to look at them, I will go over the results from your second poll. And it says, what other monitoring feature do you think would be most beneficial? We have DFU tracking coming at 20%, cluster efficiency coming in at 60%, and DFU potential problem graph at 20%. So it looks like the cluster efficiency won out on that one. So maybe that could be your next project. Okay. All right. So if we got one more, let's try to get this answered from you, and then we'll move on in the interest of time. This last question, can we track the elapsed time versus true runtime of a work unit? So if we have a bunch of work units getting blocked in our cluster, how to differentiate between the two?
So I'm still doing a little bit of investigation on exactly what's here, but here's what I'm capturing that seems to show this. If you look at the that's why I'm capturing the start and the end time. So the start and the end time gives me the total actual like wall time that it took for the work unit to have executed. And then when you look in the work unit timings, you'll see you can capture the specific time spent in spray or despray. You can get that out of there. You can get the time that was spent in compile time. And then you can gather up all of the time spent in graphs, because there's like a graph time, and I'm collecting that and summing that together to figure out how much time was it actually doing something versus how much time was it spent actually like a wall-to-wall time. And that's how we're calculating the difference between what time is spent actually doing Thor activity or despray activity versus the full time spent, where you may have been blocked. If that makes sense.